Number 51 wants the max and the minimum of this function, y equals theta minus 2 sine theta, on an interval here from 0 to 2 pi. So let's get started with our derivative here. dy d theta, almost wrote an x right there, is going to equal, and here we go, derivative of theta is going to be a 1, and then minus a 2. And the derivative of sine of any angle is cosine of that same angle times the derivative of the angle, but the derivative of theta with respect to theta is 1. So there's your derivative, guys. dy dx, excuse me, dy d theta. Now, two quick questions. Will it ever equal 0? Probably, and we'll work on that. Will it ever be undefined? No. That domain is unlimited, that domain is unlimited, and subtracting those two real numbers will always get you another real number. So, solving for this thing equal to 0, I'd bring the 2 cosine theta to the other side, and I'd write it this way. I'd just prefer it like that. 2 cosine theta would equal 1. We'll divide out the 2 and get cosine theta is equal to 1/2, and now the question becomes, where on one revolution around the unit circle is our cosine value equal to 1/2. Now again, it would be awesome if you guys just knew this, and if you do, great. But if you don't, I'm not doing a very good job teaching you guys if I just say, figure it out. So what's going on here? Here's your unit circle, and last time I drew one of these, I did a lousy job, and it kind of ruined the whole problem here. So let's try to get that circle looking right. Cosine of theta equals 1/2. Remember, guys, that on the unit circle, cosine is just your x value. I want to know where on this circle right here do you have an x value equal to 1/2. Well, at the origin, guys, x is obviously equal to 0. And right over here, 1 unit out to the right is where x is equal to 1. So x is equal to 1/2 right there in the middle between 0 and 1. And if I were to draw the vertical line that passes through 1/2 on the x coordinate, we'll see that it intersects the unit circle twice. Once right here in the first quadrant and once right below that here in the fourth quadrant. So now the question is, what angle is that? Well, if I make this triangle right here, I'm hoping you guys can see it if I drew it well, and I drew it so-so, but not great. That angle right there, everybody, is pi over 3. We've got a 60-degree reference angle right there. And then underneath that, you could call that negative pi over 3 going down here, guys, but negative pi over 3 is not in that domain. So we'd have to go around the unit circle then and make that a positive 5 pi over 3, which is in that domain of values right there from 0 to 2 pi. So we came up with two critical points right here, values at which the derivative is equal to 0, and we have our two endpoints right up here at 0 and 2 pi. So we've got 4 spots we need to look here, guys. We need to evaluate y at 0, y at pi over 3, our first critical point. I'm just going to run out of room here, darn it. All right, here we go. We're going to do y of 5 pi over 3, gotcha. And lastly, a y at 2 pi. And I'm honestly not sure, looking at this, how much of this we're going to be able to do by hand and how much we're going to need to cheat and go to the calculator for. So let's at least start trying it by hand and see where we get. Putting in the 0 shouldn't be too bad for theta. So that's a 0 minus, and sine of 0 is 0. So 0 minus 0 gets us 0. Not a bad start. All right, let's put in a pi over 3 then, guys. Obviously, when you put in a pi over 3 for theta, you get pi over 3. That's not a whole lot of fun. And then a minus 2 times the sine of that angle. So I'm talking about this spot right over here. Sine is our y coordinate, guys, which if you remember from your unit circle there in a 30, 60, 90 is root 3 over 2. But I need to multiply that by 2. So that's pi over 3 and then minus the square root of 3. Now, that's the answer, about as exacting as you can make it right there. I suppose we could get a common denominator and go from there, but it's important when you're almost done with a problem like this to know what that value is, and probably doing it as a decimal would be beneficial. We'll see. I'll come back to that in a minute. Okay, let's go to the third value now, 5 pi over 3. So that's what we get for theta, 5 pi over 3 minus 2 times the sine at this angle right here. Well, again, sine is your y-coordinate, and here that's negative root 3 over 2. Times that 2 is a negative root 3, so it's minus negative root 3, and that becomes a plus root 3. Interesting. Okay, and now let's put in the 2 pi, our last one. The theta just becomes a 2 pi, gotcha, and then minus 2 times the sine of 2 pi. Well, 2 pi is right here, guys, 0, of course, and your y value there is 0, so that's just a 2 pi minus 0, which is just 2 pi. So here's where we're at, and I'm wondering how much I can just kind of guess about this problem right here. Let me show you what I mean here. Obviously, 0 is 0. I'm not worried about that. Pi over 3, let's not get too fancy here, guys. Pi is roughly 3. So pi divided by 3 is going to be roughly 1. It's a little bit more than that, but not much. The square root of 3, I'm hoping you guys know, is roughly in the ballpark of about 1.7 something, something, something. So I'm basically looking at this as about 1 minus about 1.7. So I'm going to say that this is roughly equal to a negative, you know what, I'm going to do that in purple, sorry. You'll see why in a second. I'm going to say that this is roughly equal to a negative 0.7. That's not super precise, guys, but it might be good enough for what I need right now. Let's take a look at what's going on right here. 5 pi over 3 in the third case. Now again, pi and 3 are both, well, the pi is roughly 3, so that becomes about 1. This is basically about 5. And when I add root 3 to that, that's that 1.7 again, 5 and 1.7, so this is roughly 6.7. Okay, and then obviously the 2 pi at the end, we know that that is just about 6.28. And I actually think, guys, that without a calculator, I can answer this question here exactly the way that they wanted me to. They're looking for the maximum and the minimum values that we came up with right here. Well, let me start with the minimum. Out of these 4 values, only one of them is negative. So very clearly that negative, well, it's really pi over 3 minus root 3. That one right there has to be the minimum value because it's the only one of the 4 that's negative. Now, I want to be clear. That negative 0.7 was a lousy guess that I just made up with right there. So I'm going to just erase that. And I'm just going to say that that got ugly. Let me move the equals sign to. Okay, there we go. That is our minimum value there, guys. Pi over 3 minus the square root of 3. Let's answer that exactly. And our maximum value is going to be the only one here that, is bigger than 2 pi. It's going to be this guy right here. So that 6.7 value roughly is our maximum. But again, I should get rid of the lousy decimal approximation that we had here a second ago. Oh, and I wish I'd gotten rid of that there too. Let me just move that guy out of the way. Okay, now I feel better. So our maximum value right here, everybody, is going to be 5 pi over 3 plus root 3. Just for fun, they didn't ask for this, but this value right here of 0 is a relative maximum that we have, and this value over here of 2 pi is going to be a relative minimum. But again, they didn't ask for that. They're just asking for the max and min, and they mean absolute max and min when they put it that way. So there we go here, guys. Yep, and that matches the answers that are in the solutions manual as well, so I think we're in pretty good shape.